kilometers, it doesn't matter. So that's essentially how to do Dijkstra's algorithm. What were we actually doing? Let's go into a little bit more detail. 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6, 7. Create your grid. So we know we're starting at A and going to F. Okay, so we're at A, we can go to B, 2 steps, or we can go to C, 6 steps. I'm saying steps, I should probably be saying meters or something like that. Now, the way Dijkstra's algorithm works is basically it always goes to the closest vertex or the closest node. It goes to wherever it can as quickly as possible, and from there it goes to the next place as quickly as possible. And by going to each node as quickly as possible, you end up covering each node, and you end up covering each node in the shortest possible path. So 2 is the shortest, and now we're at B. So we've actually just taken this path and we're at B. That's why we have to add on this extra 2, because now that we're going to C, we've already travelled 2, and we're going to travel another 2. So in total, that's 2 plus 2, which is 4. So what this is saying, the fact that I said look at the above number and then look at the below number, it's actually because, well, we could go to C via this path, but that would take us 6. But we'd actually be better off going to B first, and then to C, and in that case we could get to C in 4. Could we go from B, we're at B, could we go to D? Well, yes we could, and 3, but we've already travelled the 2, and we can go 3 more, and then we'd be at D. That's the only way we can see of going to D so far, because we've only been to B so far. So that's 5, and we can also go to E, and that's our 2 and our 2, so that's going to be our 4. Now here we choose the closest node, or the closest vertex, and that's going to be that one. I just do this shading because it kind of means that we know we've been to it, and it just clears the deck a little bit. So we've just gone to C. Now we've gone to C, and we've gone the quickest way, which was via B. So we've taken 4 steps to get there. Now the only place we can go there that we haven't gone already is to D in 1 extra step. So that's our 4 plus our 1 equals our 5. Now this is quite interesting because we could either go to D via 5 steps this way. This number here represents going to D like this, through B and then straight to D. Or we can go through B and C and then 1 more step and go to D. And that would be this 5. But we could also get to another part on the graph by just going 2 steps and another 2 steps, which is the 4. So this is saying if we've explored this option and this option, we could also explore this option, and that would be a small number of steps. So we're actually going to choose to explore that shorter number of steps or shorter distance option first. So that's our E. And we've got to E, and we've gone there in 4 steps, just like that. So from there we can go to D in another 2 steps. 4 plus 2 equals 6. Or we could go to F in 4 plus 3. Well, 4 plus 3 equals 7 steps. But why would we go to D via E in 2 and 2 and 2 if we could just go via 2 and 3 or 2 and 2 and 1? There's no point. You wouldn't do it. You wouldn't go the long way. You'd want to go the shorter way. So let's forget about this 6 and go the shorter way. Either that way or that way. They're equivalently short. And we could also go, and now we know that we can get to F in 7 steps. Again, we're exploring the shortest options here, so we're going to use our 5 steps to D. Now we're at D, and we've travelled 5 steps. We've gone like that, and that, or like that, and that, and that. And now we need to get to F, we need an additional 5 steps, or 5 meters, or 5 kilometers, which is 10. And so what these two numbers are saying is, well, now we could go to B and E and F, which is this 7, or we can go from A to B to D to F, or A to B to C to D to F, which is our 10. Which one are we going to choose? Well, we're going to choose the 2 and the 2 and the 3, which is the 7. Put the 7 there, and now we know that we've been to F.